Hello guys and welcome to another video. Today we're making an editor, and as always in JavaX land it's going to be very small. How much code does an editor take? 100, 1000, 1,000,000 lines? We're going to try to do it in less than 100 lines of code, the actual editor, plus a tiny bit more for another cool feature that I will show you afterwards. So little code, less than 100 lines. How do we do it? This is Peppermint 7, a Linux system. The folks at Peppermint were very helpful in setting this up. And here's the first code. What is this? This is actually the full data model of our editor. We use Java objects, which we call, or JavaX objects, which we call concepts. Concept is a Java object with just very few additional fields. It has an ID, it's counted automatically, starting from 1, and it has the creation date. These are the main changes. And it can be persisted. Every concept is persisted automatically. Other than that, it's just a Java class. We have a session object. It just has the identity, our editor session. And we record the events. This is the idea. We record the events in the editor. This is a type event, changing the text. This is a caret move. Caret is a fancy word for cursor. Cursor is moved to another position here. And this means that some part of the text is replaced and it is some other text is added here. This structure covers all the typical editing things. Pasting something in, typing something, removing something, changing something. Anywhere in the text it will yield a very small object. This is just another way of saying subclass. I made up this syntax in JavaX. This says this is a subclass of that. This is our whole data model, just 4 classes. This is a fancy reference that can be followed both ways. This is a little helper function that applies an edit text to some text. This is our whole data model, 24 lines. And here is the editor. It's a JavaX code, 60 lines, fits on 1 page almost. We say our language level, level 7, it's the current level. We include our data model, and we have one little class that records our edits. It has a session reference here, knows the state of the editor. And here it looks for changes in the text. It receives the full new text. After something was typed, it finds the parts that have not changed. It makes this change object. And all you do here is call this little function. It makes an object of this type with these values. Just some assignments here. And plus session means that the variable called session from up here is put into the object with the same name. This is short for session equals session. And once you make some of these concept objects, they just persisted automatically. In the background, they will be written to disk. No further persistence needed. Then we even verify that our change makes sense by applying it to the old text, seeing if the new text comes out, and remembering the new text. This one is an update function for the caret. It's even simpler. When the cursor moves, we record this event. This is the whole recorder. And this is the main program. One line is enough to enable all the persistence. It saves in regular intervals that it determines automatically depending on how much there is to save. So it doesn't save all the time. It waits. If the save to look a little longer, it waits a little until it saves again. We make a new session, and this is showing the editor window. JavaX has a very short function for an editor window. We make a recorder, and if anything is updated in the text area, we send it to the edit recorder. This is the whole editor. Of course, it doesn't load. We have another program that I will show you in a minute, but it can type. So let's check JavaX. We get the latest programs here, as always. And let's start the editor. It downloads, it runs, and we are there already. This was fast. Hello, dear editor. And here in the bottom in the output window, which you can hide if you want, you can see that these change objects are generated. Every keystroke is a change. And periodically it will save all the data it has in memory, all the concepts. This is a nice test. If I remove something, it's also just one change object. It does not have undo, it's a little early, but we could do undo easily with these functions we have, right? Because we have a recorder running in the background. It's better than saving. Okay, that was this. And now let's check the second program. What does it do? It replays the last session of the editor. It starts and there we go. Automatic replay. So obviously the whole text has been saved because after the replay the whole text is visible again, and all the steps in the meantime are also saved in a compact format. This is like an eternal editor that keeps just everything, records everything you do because it loves your input. This is how software should be. Not making you do stuff, but observing you, working for you. Every pause in the original session is like, it's compressed to 2 seconds. So this is like a little bit like a fast forward replay, like a movie without the boring parts. Replay done, and we could copy this here too. If the editor is not running anymore, by the way, it will load from disk. Right now it actually the replayer contacted the editor automatically, it's all built in JavaX, to load the last session. If the editor is closed, not running, it will go to disk and get the last session from there. It's all transparent. It does this automatically. Let's look at the code here of the replayer. It's even shorter than the editor. Language level 7. Declare the maximum time for the pause. We include the same concepts file that we saw here, the data model, so we can work with the same objects. Then only one line, and we say load all the concepts from the other program. This is the only line we need to get all the data either live from memory, it actually contacts the other program through TCP, or from disk. We get the latest session object, complain if there's no session. We get all the events in the session using this nice function, sort them appropriately, and make a new edit window, and we replay. I just loop over the events. If it's a text event, we change the text. If it's a caret event, we move the caret. And then we say replay done. This is how you program in JavaX. It's so short. It's compiled to pure Java, which ends up many more lines, but not that big either. This is how big it is in delivery. It's 50K of gzipped Java source. Here's a quick look at the Java sources. It includes many standard functions. And in the beginning of the program, after the includes, there's our classes that we imported. Now it says class instead of concept. And the main program is also here. Looks almost the same as in JavaX. And all the helper functions here. This is all totally self-contained. It has no further library dependencies. It's just this one code of 7,000 something lines. And that's how JavaX programs are. Very compact, very portable too. This whole thing will work on Windows too, totally fine. macOS would work, although I haven't tested. So, welcome to the new world of programming. Let me know what you think. Get in the boat. We're going to make money and some very intelligent automation bots. Thank you very much.